What is going on? This is Mr. Martin. We are back at 2.2 solving linear inequalities. I heard you like videos, so I'm making a brand new one for you. Before we solved equations, now we're going to solve something that we call inequalities, and we're going to use those same properties of equality, and we're going to represent these solutions graphically, and of course my favorite, set notation. So I hope you've been working on that. All right, let's jump right into it. Of course, we have our things to know, and in this lesson we are talking about inequalities. That means we have a statement that compares two expressions that are not equal. So before we use that equal sign to show that two expressions were equal, in this case we are showing expressions that are not equal. Okay, and I have this chart here that we're going to fill out together, because we are going to learn some new symbols. So we have our first one, which is something that looks like this. I'm sure you've seen it all before. And notice there is no line underneath. If we have no line underneath and it is facing this direction, this means we are greater than. Okay, we also have our number line symbols. Remember, when you draw this on a number line, you need to indicate that it is not inclusive, okay, and we use a open dot for that. And then we have this new one also called interval notation. We're mostly going to use set notation here, but I want you guys to get an early peek. And when we use interval notation, if it is not including, remember, not including, we would use a set of parentheses. Okay, so we have the other side of our greater than, which is our less than. Okay, and remember, we are looking at which direction is facing our variable, and we're going to see that here in a minute. Okay, so less than, we would also use an open dot, and in interval notation we would also use parentheses. Okay, now we have our greater than or equal to. This means that the value can be any number greater than, but it can also be the number that you find when you solve your inequality. And like I said, this is greater than or equal to. Okay, and when we're on a number line, again, we use a circle, but this time it is a closed dot. So you can call it a closed dot or a solid dot. And in this case, interval notation, we would use the square brackets. So remember, these are unlike the squiggly brackets. They all have their own use. Okay, and then on the other end we have the less than or equal to. Please excuse my handwriting. Not the best on this little tablet here. And again, we got this solid dot. Anytime you see that equal to, this underline underneath, you're going to have this solid dot, and in interval notation you're going to have these square brackets. And then finally we have our straight up not equal to, and that's where we have an equal sign with a line going down, and this means it can be any number except for this number. It is not equal to this number. So not equal to. And when we do not equal to, we also use an open dot, and we're not really going to express this using interval notation, so I'm just going to leave this one blank. Alright, so we do also have another big piece of information. I have it written there for you guys in the notes, and I know this looks like a little bit of mumbo jumbo, but it's just saying if we have one expression A greater than B, okay, and K, this letter K here is being used as a multiplier. You know, we've done the multiplication property of equality. So it says if we multiply K to both sides, and remember, multiplication and division are kind of tied in as the same type of operation. If we have a value of K less than 0, okay, we actually need to flip this sign. So you see how the greater than was facing the A, and now the greater than is facing the B. So in simple terms, if you multiply or divide either side by a negative number, you must flip the direction of your inequality sign. Okay, so the addition property of equality works all the time with inequalities, but there is that little difference when we use the multiplication property of equality. So let's just see how this is actually working. So if I use the addition property, I would need to get my variable to one side. Let's go ahead and do this. Okay, let's say that I add x to both sides, and I'm doing this right now because my variable is a negative. So a negative x plus x would give me a 0. Okay, remember the sign doesn't change using the addition property. And then here I would have a positive x and this negative 5. And then now I would want to add my 5 to both sides. And I would get 5 and then the less than and the x. So one thing also that I want to remind you of, when you are reading your inequalities, always read from the variable first. I'm going to have you write this down also. Read from variable first. And what I'm talking about is we do not say 5 is less than x. Yes, 5 is less than x, but there are also so many other values that are less than x. We want to represent all of the values for x. So we would start with our variable. I call this my starting word, right? X. And then I look which direction is facing my x. And since it's the open mouth part of the little, I don't know, some call it Pac-Man or alligator, x is greater than 5. Okay, so I want you guys to really start doing that. Read from the variable first. That way when you draw this on a number line, you don't get confused. Okay, so now let's see what happens if we divide or multiply both sides by a -1. And we use that trick of flipping the sign. So a negative times a negative would be a positive. I need to flip my sign. -1 times -5 is +5. And as you can see, we have a match here. X is greater than 5. So this kind of lets you know what is actually happening with this restriction that we have here. Alright, so let's jump into some examples here. So we got our first example. We want to solve the inequality and write the solution in set notation, and we want to represent it graphically. So remember, we're doing the same thing that we did with solving equations, but this time we're just using the inequality sign and we're having multiple solutions. So we're just isolating the variable and then seeing what we get at the very end and finding a way to represent this in set notation and graphically. So I got this -3 that I can add 3 to both sides. That's going to give me a -18, and then I have this -9x. Okay, so now that I'm dividing both sides, remember, if I divide by a negative number, I need to flip my sign. So I am dividing by a negative number. -18 divided by -9 is a +2. I must flip my sign, and then I have my x by itself. So x is greater than, remember, use your starting word, x is greater than +2. So I'm going to first write this in set notation, and I do that by using my squiggly bracket, and I say x is an element of the real number system such that x, and instead of that equal sign I am saying greater than. So remember, this needs to face my variable, so you might need to do a little flip when you write it in here. Just make sure the same direction is facing your variable. Okay, then I have this 2, and then I close my bracket. And then remember, when you draw your number line, you can just give me the 0 and the value that we're looking for. And I am only greater than, I am not equal to, so I know that I have a open circle. And greater than 2 means I am going to the right on the number line, so I am including all of these values to the right of this +2. Alright, example B, we are going to first clear out this fraction by multiplying both sides by a +2, so no sign flips here. We then get negative 4 less than or equal to x plus 7. I can subtract the 7 from both sides and I get negative 11. Okay, so this might want to trick you. Just because we have a negative solution here does not mean we flip the sign. Only when you divide or multiply by that negative number. Okay, so set notation would give me x is an element of the real number system such that x, and remember this needs to face my variable, is greater than or equal to negative 11. And then I have my number line here. And I want all the numbers greater than or equal to, so I'm making sure I use a solid dot, and I am going to the right. All right, very good. All right, so example number 2. We have the same type of instruction. We are still solving inequalities, but if you look at letter C, we are doing the not equal sign. So now we have a variable on both sides. Remember, this can be solved multiple ways. I always like to move the variable first, so that's what I'm going to show you here. But remember, you are free to solve any way you like as long as you are following the steps appropriately. So 5x minus 2x gives me a positive 3x. This plus 3 will drop down. Remember, we have a does not equal sign, and then we have our positive 9. We're going to subtract 3 from both sides. We get 3x does not equal positive 6, and then we divide both sides by 3, and we get x does not equal 2. So our solution set is any value on the real number system except for the value of positive 2. So we're going to write this the same way. X is an element of the real number system such that x does not equal positive 2. Okay, and then the part that might be a little new for us is how do we write this on the number line? Well, we have our 0, we have our positive 2, and remember, if we are not including the value, we have an open circle. So I want to be able to represent every number except for positive 2, and I do that by going both directions on the number line. Okay, and we must use this open circle here. Okay, go ahead and pause the video. I want you to try letter D on your own. Come back and see what you get. All right, welcome back. Hopefully you got the same thing I did. After I did my distribution, I was able to get rid of the 6x and it removed the variables completely. And then remember, if your variables disappear, you need to look for that true or false statement. In this case, positive 3 is greater than or equal to 2. So we know that if we have a true statement, then that's one of our special case solutions, meaning we have all real numbers. So I indicated that down below by graphing the whole line. All right, let's take a look. What else do we have here? Okay, go ahead and pause the video. These look pretty similar to the ones we did before, so I'm going to have you pause here, crank these out, and then come back to the video and see if you got the same thing. All right, welcome back. So for example E, we had no solution. Remember, keep an eye on this. Sometimes when you see that same value, you want to think that it's a true statement. But remember, greater than 16 does not mean equal. It's not a greater than or equal. So because there's no line here, this is indeed a false statement. All right, and then here we have x is greater than 6. All right, let's go to another example. All right, I'm going to let you guys do this one. So go ahead and pause here. We just actually have a bigger inequality. We have a little bit of some big distributions going on all over the place. Remember, you always want to distribute your coefficients and your signs. So go ahead and try these, see if you can get them, and then come back and see what you got. All right, welcome back. So if you take a look here, hopefully you are on the right track. I just want to talk about letter G real quick. After you distribute, remember, you want to combine any like terms you have on the left and then combine any like terms you have on the right. So here on the left, this negative 4p and this negative p make a negative 5p. And then here you actually have two sets of like terms, this negative 2p and this negative p, and then also this negative 14 and this negative 6. So don't forget to combine those like terms, then start doing your addition and subtraction on both sides if you need to. I have my set notation here and then the graph, and then for letter H we had r is greater than negative 2. Alright, well, I hope you enjoyed this lesson. Make sure you do that practice. Remember, practice makes perfect. I should say perfect practice makes perfect. But remember, if you need help, ask me, ask a friend, ask a family member. Definitely check out tutor.com. They are more than willing to help you. I will see you on the next one. Peace out.